Today, we're diving into some exciting new developments from Hypixel Studios about Hytale. It's been quite a wait since the last major update, but now we've got a fresh blog post to unpack. Buckle up, because there's a lot to uncover, including insights into the game's development and what's in store for the next big update. First off, it's great to see Hypixel Studios stepping up with this early summer update. Unlike their usual biannual announcement, this blog marks a new approach, focusing specifically on technical updates. It's a nod back to their earlier, more frequent updates back to 2020, but with a deeper dive into the engine behind Hytale. Speaking of which, they've introduced a new engine architecture called Flex, and they're really enthusiastic about its potential. For those not versed in game lingo, don't worry, I'll break down what this means for you. Essentially, it's setting a stage for smoother gameplay and future updates. What's impressive is their clarity and communication. This isn't just another routine update, it's a deliberate effort to keep technical discussions separate from the big summer reveals we're all eagerly waiting for. This blog lays the groundwork, preparing us for what's next without overwhelming us with too much technical jargon. So while we may not see drastic changes in gameplay just yet, this post gives us a sneak peek into the meticulous work happening behind the scenes. It's all about maintaining that Hytale essence while pushing boundaries with new tech. I'm excited to see how this unfolds, especially with the promise of more detailed tech explainers like this in the future. It shows Hypixel Studios is listening and evolving their approach to keep us informed and engaged. The blog starts off diving into the technology behind Hytale's engine, focusing on a framework recently announced by Hypixel Studios, Flex, a lightweight and powerful entity component system, or ECS. Hypixel Studios decided to reboot the Hytale engine, transitioning from a Java server and C# client to building both components in C++. This change was driven by the need for multi-platform support, improved performance on lower-spec devices, and the desire for a robust core engine that can easily be patched and maintained in the future. ECS is a key tool in achieving these goals. This blog post will cover why Hytale chose Flex as the ECS foundation for Hytale's new engine and how it helps them meet their objectives. Before diving into Flex though, let's explore what an entity component system is. ECS, or Entity Component System, might not be a brand new concept in game development, but it can still be tricky to wrap your head around at first. So let's break it down in context of how the games are made. In traditional game development, a lot of work relies on something called object-oriented programming, or OOP. This approach breaks down problems into objects that are easy to understand and work with. Think of it like building with Lego bricks. Each block represents a different piece of the game. For example, imagine you have a character object in your game. This character object includes common features that all characters share in the game. From this character object, you can create more specific types like a player character, different NPCs, and other characters you need. It's like having a base model Lego piece that you can modify to create different figures. But this approach can get really complicated and unwieldy. As you add more types of characters, the structure becomes broad and hard to manage, like trying to build a giant Lego city where every block has a different function. Entity component architecture is a fundamental concept in modern game development and is used by popular game engines like Unreal and Unity. But what does that actually mean for us as gamers and modders? Imagine every item or character in-game as an entity. These entities could be a player, an NPC, or even something simple like a chair. Now, these entities aren't much on their own. What makes them interesting are the components attached to them. Think of components as modular pieces of functionality and data. For instance, a player entity might have components that define its position in the game world, handle controller inputs, and manage inventory. An NPC might share some of these components, like position and inventory, but also have components for AI behavior. Even a chair has a position component, and if you wanted to get creative, you could add a behavior component and make it move. This system, known as composition over inheritance, allows developers to mix and match components to create complex behaviors without creating complicated hierarchies. It's like building with Lego blocks where each block adds a unique feature. For modifiers, this is a game changer. You can tweak or add components to entities to drastically change their behavior without touching the underlying game code. Want to create a new type of NPC with special abilities? Just add the right components. This makes the game highly customizable and opens up endless possibilities for creating new content. But this still isn't ECS. In traditional game development, each component manages both its data, like position or health, and its behavior, like movement or interaction. ECS separates these. Components hold data, and systems handle behavior. Systems process entities based on the components they have. This separation boosts performance by optimizing how data is accessed and processed. It aligns well with modern CPU architecture, allowing tasks to run faster in parallel. Essentially, ECS makes games more efficient and scalable, crucial for handling complex situations and interactions smoothly. In their journey with the legacy engine, Hypixel Studios recognized the potential of ECS, Entity Component System, early on. ECS was seen as a key to enhancing performance and scalability, aligning perfectly with their data-driven approach to building game entities and actors. Initially, they implemented their own Java-based ECS framework for the server side, but it lacked an equivalent for the C# side, limiting their implementation to the server environment. Integrating ECS meant refactoring existing logic and gradually adopting new functionalities. It was a challenging process that taught them valuable lessons. Developing a robust ECS framework from scratch demands deep technical expertise and meticulous design considerations. Despite Java's performance limitations, their implementation still delivered noticeable performance gains and introduced a more flexible system architecture that embraced data-driven design principles. This approach not only boosted performance, but also empowered modders. By simplifying how data influences game behavior, they aim to make modding accessible even to those with minimal technical expertise. Kind of like me. When Hypixel Studios rebooted the engine, they were committed to leveraging ECS for both server and client side to maximize its benefits across all aspects. Moving to C++ opened up opportunities to explore existing ECS frameworks rather than developing and maintaining their own, potentially discovering cutting-edge features that could push the paradigm even further. After thorough evaluation, they selected Flex, a refined ECS framework crafted by ECS expert Sander Martens. Flex offers a comprehensive suite of features typical of ECS implementations, coupled with outstanding performance and compatibility across multiple platforms. Its implementation in C with a C++ API ensures superior speed, optimizing parallelization, and multi-threading capabilities to its fullest extent. Moreover, Hypixel Studios benefits from not needing to maintain Flex themselves. It's battle-tested, regularly updated, and rigorously tested for stability. One of the standout features of Flex is its support for relationships along components. These allow entities to connect and interact dynamically. For instance, establishing a parent-child relationship like a player having a camera that follows it. Another innovative use is in defining relationships such as entity A likes entity B, enabling powerful queries like finding all entities liked by B. And ECS operates much like a database, and Flex fully embraces this concept. Its rules engine is a powerful tool for querying data in various ways, from simple tasks like updating crop growth based on attached components to complex queries for game logic or debugging, such as finding aggressive NPCs with swords targeting the player. Flex also introduces a component sharing feature that allows defining a base actor type, such as a character, and treating both NPCs and players as characters. This combines the benefits of object-oriented programming inheritance with ECS optimizations, making game development more flexible and efficient. While these features may seem complex at first, mastering them unlocks powerful tools for building games. Let's dive into a practical example of this. Previously, Hypixel Studios introduced a feature in Hytale called the Combat Action Evaluator for NPCs. This framework enhances NPC decision-making by allowing them to choose attacks and targets more intelligently based on configurable inputs. Originally developed for the legacy engine, it was designed to be data-driven from the start, with each input managed like components in an ECS. While effective, this system had its limits in the legacy engine, particularly in managing the performance impact of processing large amounts of data for NPCs' decisions. Due to these limitations, the evaluator operated intermittently to prevent server slowdowns during immense combat scenarios. This cautious approach, however, sometimes resulted in slower NPC reactions noticeable to players. With Flex, these performance concerns are significantly mitigated by redesigning the framework around ECS principles and leveraging Flex capabilities. Hypixel Studios can now process NPC decision-making much more efficiently. In practical terms, this means NPCs can react faster to changes in their environments and make decisions more responsively than ever before, enhancing gameplay dynamics in Hytale. Now, I understand that this blog has been a ride, and I tried my best for you guys to understand what this means. Note that this is once again a technical blog post. We are still expected to see the summer development blog post come within the next few weeks, which has been confirmed to show new gameplay and screenshots of the new engine. Like I said earlier in the video, I think this blog post is meant to get rid of the technical stuff that was originally expected to be in this new engine showcase. It gets rid of the boring stuff, and in the development blog post, we'll get straight into the action for what everyone here wants to see, and that is new gameplay. If you want to stay up to date when this blog post drops and exactly what it says, make sure you subscribe to the channel. YouTube thinks you might like the video on screen now, so why not give it a try? See if YouTube is correct.